Okay, here we go with note 7, classifying polygons. It says, how do you classify polygons? Well, basically you classify a polygon based on its sides. A polygon, by the way, is a closed plane figure that is formed by at least 3 or more line segments just called segments, is the sides. And then each side intersects exactly two other it intersects exactly two other sides, one at each end point, so that no two sides with a common endpoint are collinear. Remember, collinear means in the same line. Each endpoint of a side is a vertex of the polygon. So basically, if over here on the side I draw let me draw a pentagon. Each one of the ends, or the points here, represent a vertex, and these guys are segments, or basically sides of the polygon. This one happens to be a pentagon because it has 5 sides. You have a hexagon, 6-sided. You have a heptagon that is 7, an octagon that is 8, a nonagon that is 9, and a decagon that is 10, and it goes on from there. But those are your basic ones that you deal with. A closed figure means that, here, and I'll draw it in this little space here. In other words, it does not look something like this, where they do not end up touching back together. That is not a closed figure. Okay, hush. Shh. Okay, next vocabulary here. It says a polygon is convex if no lines that contain a side of the polygon contain a point in the interior of the polygon. So convex means that basically it's pushed out. It's like putting a balloon inside of it, blowing it up, and pushing all the sides out. So if you were to have a hexagon, it would look somewhere like this fashion, kind of blown out to the sides. A polygon that is not convex is called non-convex, but a better word than that is that it is called concave. Concave, a hexagon that is concave. If I can try to draw it, these are uncommon. Let's draw it. Okay, that's not a hexagon, but it's curving in. Therefore, a point is on the interior. That is a concave shape. When we get above 10, sometimes they will just call an entagon a polygon, where the n represents the number of sides of the polygon. So if you get 11-agon or 12-agon or 13-agon, those actually have names in the Greek terminology, but we don't use them very often. We'll just call them entagons. An equilateral polygon. Realize lateral represents sides. Equal means that the sides are all equal, and if they are congruent, then it's called equilateral. Likewise, if you have all the angles being congruent, this is called equiangular, where you can see inside the word it has basically the word angle, so they're equal angles. And then if it is both equilateral and equiangular at the same time, they actually change it to just saying that this is a regular shape, and that's usually what we deal with in geometry. Realize a regular shape, suppose I had a triangle. They'll have the same markings as well as the angles. They'll have identical markings there, indicating that this is a regular shape. Okay, on example number 1, we want to tell whether it's a polygon or not, and then if it is a polygon, is it convex or concave? So if I zoom in for number 1, if I can get the light to shift, maybe come out a little bit. if I'm looking at this particular shape, I notice this point is more towards the center of my shape. That means it is caving inside. So that means this is a concave shape. And since all the points have exactly one vertex, that means this is actually a polygon. So this is a concave polygon. The second one, if I look at this fact that this is curving in that fashion, that makes this not a polygon. I mean, that's straight out not polygon, because this is a curved line, and that curved line is not a segment. A segment is a straight piece, part of a line. I'll just stop there. I can't classify it as concave or convex. It's just that. On letter C, look at all the sides. They're all straight edges, and they're all contained inside the shape. You don't have any open pieces, so this is a polygon. And since we have several vertices that are going towards the center of my shape, this one is also concave. And then this last one has vertices, has 5 of them. That means it's a pentagon. This is a polygon. It is closed. And then all my points are kind of pushed out. They're not curving in at all, so this is a convex. And this is a shape you're typically used to seeing. Okay, if we're looking at the next page, it says classifying polygons by the number of sides. It says tell whether the polygons are equilateral, equiangular, or regular. On the first one, this is 4-sided, so that means its name is a rectangle. Okay, it is a rectangle because it has 4 sides. B is 1, 2, 3, 4, 5, 6, 7, 8, so that means it's an octagon. Okay, and then on C it is 3 sides, so that means it is a triangle. So that's the first part of naming it. It says classify the polygon. So that's the first part. Then it says tell whether your polygon is equilateral, angular, or regular. Okay, so on the first one, if I'm looking at the markings, I have the sides have different hash marks. So I have these two and these two. Those 2 sides are congruent, but not all 4 are congruent. So that means it's not equilateral. If I look in the corners, notice they all have the same markings. They're right angles. So that means it is equiangular. And my explanation is all angles are equal. Okay. Oops, I didn't see that. On B, if I'm looking at this, you look at the sides first and notice they all have one single congruent mark on the side. All sides are congruent. And then all angles, if I'm looking at it, see all the arcs, they all have exactly one arc on them, so that means all the arcs are actual angles are congruent. So for the octagon, they have both angles and sides are all congruent, so it is equilateral, equiangular, but when they're both, we actually just call it regular. So this is a regular shape. And my reason is all angles and sides are equal. Okay? On part C, if I'm looking at the sides, I have a 1 and then a 2 and then a 1, 2, 3. So none of the sides are congruent. If I look at the angles, there's 1, there's 2, and there's 1, 2, 3. None of the angles are congruent. So the only way I can classify this is as a triangle. I cannot say that it is equilateral, equiangular, or regular. So there is nothing else to classify this shape by. That's where it ends. All right, example 3. It says, okay, well, this figure is a regular pentagon. Regular, once again, means that it is both equilateral and equiangular. So everything is equal. They want us to find the length of a side of my pentagon. Remember, a pentagon is 5 sides. Okay? So if I look at my picture, and that was not supposed to be there, they give me this top edge, and I know it's going to be equal to this bottom edge because it says it is regular. So these two expressions are actually equal to each other. So if I'm going to find out where the side is, I'm going to have to find x. To do so, I'm going to have 2x minus 1 is equal to x plus 3. If I do my math, that would be subtract 1x from the left side, and then I bring everything down. I'm going to add 1, and I realize that x is equal to 4 for this part of the problem. Now the question, remember, was find the length of a side, a single side. So you can pick either expression, it doesn't matter which one, and plug in the 4. And when I plug it in, I'll have 4 plus 3, which is 7. And just to show you, it doesn't matter, I'd have 2 times 4 minus 1. 2 times 4 is 8. 8 minus 1 is 7. So either one of these will work because that tells me the side length is 7 centimeters. Okay, here are your independent practice problems doing kind of the same thing that I just did on the notes. So you work these and we'll check them on Monday to see if you have the correct answers, and make sure you have your summary answered on Monday so that you can get 100 if you have everything worked. See you then. Bye.